All right, let's do this. Go over these multiple choice questions. So this number 7 kind of perplexed me a little bit. Which conditions for inference have been satisfied? Okay, so you're random, you're independent, you're large enough. So first of all, when I was reading this problem, the first 35 students who have walked through the door, okay, that right there is a red flag. I knew it from reading that first sentence, because if we're talking about traveling time to school, and we're talking about the first 35 students who walk in the door, I'm pretty sure that's going to be a biased result, because who gets there first? People that didn't have to go as far, or some other quality. Okay, so I just don't think that that's a smart. That's not a smart sampling method. It does not employ randomness. So 1 is out. That condition has not been successfully employed. Okay. Now, the next one, the sampling distribution of the sample means is approximately normal. Yes, because the 35 students is the sample size, and if it's greater than or equal to 30, then your sampling distribution is approximately normal. All right. Now, this one, I was kind of like, I wanted to say no. So I truly, my first instinct was 2 only, because it says the sample size is small relative to the population. And I was like, that doesn't matter as long as it's greater than or equal to 30 and less than 10%. So my first instinct was 2 only. But then I was like, that's not an option. Okay. So something's going on here. Well, I just know it's definitely not 1. So I went back and I rethought about number 3. Well, I think that what number 3 is referencing is that 10% condition, saying something like that the sample size is less than 10% of the population. It's small relative to the population. Okay, that's what that's referencing. So therefore, it has been met. 35 is less than 10% of 4,000. So 2 and 3 would be the ones for inference that have been met. All righty then. So here, lots of words, lots of numbers, and yet one of the most important words that you needed was in important numbers you needed was in word format. Right here, 15 ounces, 20-ounce bottles. So the sample size was 15. Okay. So here is our sample mean minus the hypothesized value we are testing it against. And here is the standard deviation of the sampling distribution, the standard deviation of the sample divided by the square root of n. Okay, so there's that one. Number 9. Okay. This was another one. I mean, I'm telling you, is so interesting. You got all this stuff, all this information. I'm like thinking, okay, I'm going to have to perform a test. What am I doing? What am I doing? And then bam, it just says, what's the probability of a type 1 error? Well, we know from our last unit that alpha is the same as the probability of a type 1 error. So ding, 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 there you go. Alpha is 0.01, so the probability of a type 1 error is 0.01. Okay? All right, here we go. Interpretation of the p-value. The p-value is 3 things. The probability of getting this sample or something more extreme if the null is true. So let's go find those things. A and B are out. It's not the probability the null is true or the alternative is true. C, D, and E start off nice. If the null is true, then the probability is 0.031. Okay. D also said that. D also says that the probability is 0.031. Okay, so they all said that the probability is 0.031. Where they went wrong, or what differentiated the correct answer out, is the probability of getting this sample or something more extreme. Okay, so what that is getting this sample or something more extreme. Okay, so here was the sample results, see, of getting that sample or something more extreme. And so that is going to be the E. Oh, I forgot to circle an answer here. Yeah, A, B, C, and D all had something wrong with them. So E is the right answer on this one. Okay. All right. Number 11 is saying all this information. I was thinking, this is weird. They want to know about the true mean is one. Anyway, I was like, this, I don't understand. I don't know what's going on. But then when I read the question, he says the power is 0.9228. So what's the probability of a type 2 error? Okay. And then I went, all that other stuff. The whole first 5, 6 lines, not even needed. All I really needed was this. He determines the power is 0.9228. So what's the probability of a type 2 error? That's all I needed in this whole problem. So, I think one of the other skills you're learning is how to sort through extra information. Okay, and there was lots of it here. Well, power plus beta is 100% of the data. So power plus that probability of a type 2 error, because that's what beta is. So power 1 minus power is your 0.0772. And then here we have this last one. So here's this scenario talking about the average salary and of the college graduates. And so a university was wondering if the average salary of their graduates is actually higher than $45,327. So that's the alternative they were wondering about. So they had a p-value of 0.045. Well, if we compare that to your alpha, it's lower than your alpha. So I reject HO, and there is convincing evidence that the average salary of their graduates is greater than $45,327. So I just looked for that one. So A and B both said that there's convincing evidence, okay? So then I had to go dive deeper. So A says that the average salary for all recent college graduates. B says convincing evidence that the average salary for the sample of the 10. Nope, it's not about sample. It's about all. Okay, you are inferring about all using that one sample of 10. Okay, all right, I think that was the end of the multiple choice for this assignment, but then we had 3 AP Tester Trio questions from our Unit 1 on sampling. This one just asked you to identify treatment, experimental units, so those are the subjects that are being experimented upon, and then the response that's being measured. And of course, the treatment is what you're testing out. So we were testing out the 3 different storage times. We were testing it on the freeze-dried fruits or the package of fruits. And the response we were measuring was the amount of vitamin C that they had in them. So that was answer D. Number 2, so this was describing an experiment, okay? And we were talking about the response we were measuring was the exam grades, and the treatment that was intended in this problem was having coffee. So one period had coffee, and the second period did not have coffee. So the intended treatment that we were testing was caffeine via coffee or whatever. However, there was another difference between the 2 classes of the instructor. So what happens then is we can't tell when one of them does significantly better, which it says there's a significant difference in their exam scores. We don't know why. Is it because one got caffeine and one didn't? Or is it because there's a particular instructor and over the other? So we don't know. That's confounding variables cloud the issue. You can't claim a cause. All right. Number 3, which is a reason that this could not be double blind. So I just kind of reminded you that double blind means that neither the subject nor the administrator or the evaluator, depending on how it's designed, knows which treatment the subject receives. So the treatment, by the way, was not this boy and girl stuff. So 3 of these answer choices referenced knowing if the subject was a boy or a girl, and that did not have anything to do. That was not the treatment that we were testing. We were testing the flashcards versus the computer. So the treatment was flashcards versus computer, not boy or girl. Therefore, the reason it couldn't be double blind is because the child will not know whether he or she used the flashcards. We know that for a fact. The child will know if the child is using flashcards or a computer. Now, E says this: the person who grades the test will know whether the child used flashcards or the computer. I mean, I don't know that. That could be hidden. So, see, that could be hidden. So, I don't know that that's definitely going to happen. That is not the reason why this is impossible to be a double blind experiment. It's impossible to be double blind because the child will know. So, there you go. All right, I think that's it. So I hope that all that made sense to you, and I hope that you're getting some good review out of those AP Tester Trio flashbacks.